Okay, so we've talked about how there was a problem yesterday, x squared plus 9 equals 0. Answer was not a real solution, or no real solution, which is true, but there is technically a solution. So we have to talk about this new group of numbers that you're not used to. And it starts out with some basic information. Now, I know it's going to seem a little bit weird. And maybe I should glance over here and take a look at this. The imaginary unit I. You're like, imaginary? Well, one group of numbers is called the real numbers because that's the group of numbers that you're used to dealing with, and your calculator is very capable of handling. But what about groups of numbers that are based on this information right here? The square root of -1. That's not a real number. You cannot find two numbers that multiply together to give you -1. So we represent it with the letter I. So this creates a group of numbers that are separate from the real numbers that have an unfortunate name called the imaginary numbers. So all the kids are like, well, if they're imaginary, why do we have to deal with them? Well, what happens when you square? When you take I and you square it, right? That's the square root of -1, and you're squaring it. Well, that's what you get right here, which is very unusual because what you get is a real number. So when you multiply two imaginary numbers together, you get a real number. That's unusual. That's not normal. So we can simplify. I'll come back to some of the other things that are on screen. We can simplify this a little bit. For instance, square root, that's the square root of 121 and the square root of -1. Well, that's 11i. You get your 11 from the square root of 121. You get your I from the square root of -1, and so that is literally the simplified answer to the question. So here, this is 3. This, right, that's square root 36, square root -1. So that's 3 times 6i. Now, when we finish these questions, we are going to treat I just like any other variable we've ever dealt with. There is one situation we're going to watch out for, which we'll talk about later. In this particular situation on part C, there's no perfect square which goes into 29. So the only thing I can do is disconnect that -1 from the 29, which gives me I square root 29. Now, you might say, well, Mr. Staley, why can't we write radical 29i? Well, truthfully, you can. But then what happens when people start getting sloppy, right? And then all of a sudden that radical goes over the top of the I. Well, that's a problem because that's not the same. So in order to just avoid that confusion, we just put the I on the outside of the radical. Okay, about a little bit more of this. So every time I split this up, now I'm just going to take the negative with the perfect square and leave the extra trapped inside. So we've got 2i radical 3. All right, let's see. What's the perfect square that goes into 108? I don't think 8 does. Oh, let's see here. Well, I know 4 does. I bet that's not the smallest thing. But let's check it out. So I'm going to take the negative with the 4. 4 goes in 2 with, carry the 1. Oh, No, yeah, 27 times. That's right. Oh, now I might have shown you in class how we could break it up. So obviously 4 is not the biggest thing that goes in. 36 was. I'm going to break this up into 9 and 3. And we still got the square root of -4. Oops, not the same thing. Okay, so I got 2i, I've got 3, and then I've got a 3 trapped inside. So 6i square root 3. Now, had I just gone straight to the -36 and the square root of 3, then I would have gone to that right away. So it's always nice if you can pull out the greatest perfect square, but sometimes you just don't think of it right away. Okay, so 2 and -9 with a 6 trapped inside. So let's see here, that's 2 times 3i radical 6, or 6i square root 6. You can always pause these videos and then kind of digest what I've written in case I went too fast. Always digest. Now that's just simplifying radicals. Okay. What about if you combine a real number and an imaginary number? Okay, so the real numbers, big group of numbers. Imaginary numbers, big group of numbers. But then, if you combine these together, you get an even bigger group of numbers called the complex numbers. So, complex numbers, that's the biggest group. That's the biggest group that we've talked about. And the real numbers are hiding inside of the complex numbers. So you've got a real part, and you've got an imaginary part, and you add them together. That's called a complex number. Now, when you are in elementary and middle school, they might have said to you, find x equals 3. And you're like, oh, Mr. Staley, I can do that. X equals 3 is a dot right there on the on the number line. Right? Well, what they never showed you was there was another axis running through here. In other words, we've got the real axis, and then the one that they never showed me was the imaginary axis. This is called the complex number plane, or the complex plane. Complex plane. That'd be a good name for a plane if I ever own one. You know, I'll just call it complex and see if anybody pays attention. Okay. Now, the dot that I put on there for 3 is really 3 plus 0i. 3 plus 0i. Yes, I know, nobody ever wrote 0i. We didn't want to scare the children. Well, then there's 3 plus 2i. Well, where's that at? Here, 3 plus 2i. Not sitting on the not sitting on the real axis. It is off the axis. How about 3 minus 2i? Oh, that's down here. Now, what is absolute value? Absolute value is a distance away from 0. What do we know about distances? They're always positive, never negative. So if they ask me for the absolute value of 3 minus 2i, what are they really asking me for? They are asking me for the distance from 3 minus 2i to the origin. Is that really 3? No, it is not. How do we find it? Well, geometry fans, I've got one side of that triangle, which is length 3, and one side of the triangle, which is length 2. How do I find the hypotenuse of a right triangle? That's right, folks, the Pythagorean theorem. A squared plus b squared, and then I take the square root. In this case, that's 9 plus 4, which is 13. So the distance is the square root of 13. So complex numbers have a real part and an imaginary part. And they're just being added together. Let's see what else we can learn about them. Can we put them together? Yes, we can. Now, this is addition, so let's not get all bent out of shape. We're just adding these things together. Now, the real numbers get added together. The imaginary numbers get added together. And we're done. Now, the next one, subtraction, I'm going to distribute the negative, and I'm going to change it from subtraction to addition because you guys do much better with addition than you do subtraction. So, negative 2 and a minus 5i. And now I have changed this to addition, and I'm back to the same thing I did on the previous question. 12 plus negative 2, 11 plus negative 5i. So, positive 6i. When you see radicals with negatives or that are not simplified, we need to simplify them first before we do anything else, okay? So 2 minus 4i minus 8 plus 12i. Well, now we can do what we did on the last example. Distribute the negative 1. And then change it to addition. And so I get negative 6 and a minus 16i, and that's the answer to my question. Negative 6 minus 16i. So simplify those radicals first before we change it from subtraction to addition. But yeah, you want to treat I like it's just like x. But there is one difference. At the end, replace all I squareds with negative 1. So just keep in mind, I squared equals negative 1. So when I do this, when I do this and I get 24i squared, because I treated the variable, I treated the i's just like I would at x's. But that's really like saying 24 times negative 1, which is negative 24. So that means the b right after that is negative 5i times negative 5i, because squaring something means you're just multiplying it times itself. 25i squared, which is really 25 times negative 1, or negative 25. Every time you see I squared, replace it with a negative 1. So here we're just doing FOIL, right? Now, I don't care if you use a box, don't use a box. 3 minus 7i and negative 2 plus 6i. You get negative 6 and 18i and 14i. And then lastly down here in this corner is negative 42i squared. And that's the same thing as negative 42 times negative 1, or plus 42. Oh, those two are like terms, and these two are like terms. 42 take away 6 is 36. 14i plus 18i. What is that? 32i. So you just have to remember that the I squared is equal to negative 1. Okay, on D. 11 4i, 11 minus 4i. And let's see here. We got 121 minus 44i plus 44i and a minus 16i squared, which is negative 16 times negative 1, or positive 16. So we end up getting 137. Well, yeah, those i's cancel out. We just get 137. That's it. Because you add the 121 and the 16 together. Yeah, these add up to 137. Nice. All right, so subtract 49, and we get x squared equals negative 49. Take the square root. X equals plus and minus 7i. Divide by 2, divide by 2. X squared equals negative 48. Take the square root. X equals, okay, so 16 goes into that. Take the negative, and don't forget your plus and minus. Negative 16 goes into negative 48 3 times. So we get x equals plus and minus 4i square root 3. Final answer. If I multiply by 3 on both sides, I get x minus 2 quantity squared equals negative 81. If I take the square root of both sides to get rid of the square, I get x minus 2 equals plus and minus 9i. Then I'm going to add 2 to both sides. Those are not like terms, so I'm going to leave them separate. So it's really like having two answers, right? 2 plus 9i and 2 minus 9i. But in order to and these have a special relationship. These are called conjugates. So the real part is the same, only the imaginary part is different. Imaginary part opposite. So I'm going to subtract the 8 to the other side, giving me x plus 4, quantity squared, equals negative 50. If I take the square root on both sides, that would give me, sorry, I have to separate this, x plus 4 equals plus and minus, see, that's going to be square root negative 25 times the square root of 2, 5i radical 2. And then we want to get x by itself, so we'll subtract 4. So x equals the opposite of 4 plus or minus 5. I. Radical 2. And I think that's all for this particular set of notes. We are getting ready for our test.